In the 14th question we are given the Fibonacci sequence is defined by 1 equals A1 equals A2 and then you take sum of two consecutive terms to get the next term, right? That's the Fibonacci sequence. It is a very famous sequence. A1 is equal to A2 is equal to 1 and then you have AN is equal to AN minus 1 AN minus 2, right? This is what you have. What does that imply? A1, A2, A3, A4, A5, if these are the terms of the sequence, A1 and A2 are 1 and 1. A3 will be A2 plus A1, sum of these two. Then A4 will be sum of the previous two terms, which is 3. A5 will be sum of these two terms, which is 5. And if you continue further, the next term will be 8 and 8 plus 5 will be the next term. Then continuously adding them will give you the sequence. The Fibonacci sequence is defined by this. Find AN plus 1 upon AN for n equals to 1, 2, 3, 4, 5. Okay. So for 5, this is A6. So at least write up till A6. 5 plus 3 is 8. Over here, this is A6 for us. Okay. If you want, you can find A7, A8 as well, right? The sequence looks like this. 8 plus 5 is 13. 13 plus 8 is 21 and so on and so forth, right? This is what you get. This is the sequence. But the person is not actually interested in the sequence. The person is interested in the ratio of these terms. And there's a special relation about that ratio. I'll explain that also. Over here, Fibonacci sequence is defined by this. And what do we need? Ratio of AN plus 1 upon AN. AN, this ratio. So first of all, let's take n equals 1. This tells me A2 upon A1 is equal to 1 upon 1, which is 1. Then you need A3 upon A2 is equal to, this is for n equals 1. For n equals 2, this is what you get. A3 upon A2, which is 2 upon 1, which is 2. N equals 3. This is A4 upon A3, and what is that equal to? That's 3 upon 2. What is that? A4 upon A3 is 1.5. N equals 4 implies A5 upon A4 is equal to 5 upon 3. This is what you get. N equals 5. This tells me A6 upon A5 is equal to 8 upon 5. By the way, what is this equal to? 5 by 3. This is 1.666 and dot dot dot. This is 8 upon 5 is 1.6. This is what you are getting. Is it okay? Yes. Can you take a look at this particular value? For n equal to 5, you have A6 upon A5, which is equal to 1.6. These are the values of an plus 1 upon an for n equals to 1, 2, 3, 4 and 5, as you can see over here. Now the special thing about this particular ratio of two consecutive terms of this sequence is that the ratio actually tends to a particular value, when the value of n becomes sufficiently large. When the value of n becomes sufficiently large, this ratio tends to a particular value over here. What is that particular value? Where are we? Okay. What's that particular value? So, that particular value that I'm talking about is approximately it is 1.618 something. This is. And this is a particular value. This particular value is actually called the golden ratio. It's called the golden ratio, and it is found at many places in nature in general, and it is also related to this Fibonacci sequence, as we have seen, right? One important concept and one important mathematical concept, actually not useful for NCERT, but then this particular ratio directly relates to this particular thing over here. Okay. And with this, we come to the conclusion of this exercise from the chapter Sequence and Series. Till the next lecture, all the best.